Okay, so the first question asks us to calculate the modulus of elasticity for an alloy, and the diameter is given as 8 millimeters, tensile force is 1000 newtons. This is the reduction in diameter, and Poisson ratio is given as such. So if you were to write these once more, diameter is 8 millimeters, tensile force is 1000 newtons, reduction in diameter is 2.8 times 10 to the power minus 4 millimeters. Poisson's ratio is 0.3. We need to find the Young's modulus. So let's start with what is happening to the material in this problem. This is our coordinate system. We are applying uniaxial tension, and first we must define what Poisson's ratio is. It is the ratio of lateral strain to the longitudinal strain. So if you define your coordinate system as such, it is the strain in diameter to the strain in the length. So the strain in the length can be calculated by simply delta L over L0, and the strain in diameter can be calculated by change in diameter over D0. And we also have, for linear elastic deformation, the Hooke's law. First, let's start with the calculation of that strain in diameter, which is delta D over D0, and this is minus 2.8 times 10 to the power minus 4 divided by 8 millimeters. That is going to be 3.5 times 10 to the power minus 5. As you know, strain is unitless. Then Poisson's ratio is known as 0.3 given in the problem. Be careful to include this minus sign in the Poisson's ratio expression. Then we will have our longitudinal strain as 1.167 times 10 to the power minus 4. So we have our longitudinal strain. So we also need to calculate the stress. Stress is a simple expression, P over A0. The load to apply to the sample is given as 1000 newtons, and A0 can be calculated from, since this is a cylindrical rod, it's going to be pi d squared over 4. And we also know the diameter as 8 millimeters, so we substitute those as well. This gives us a stress of 19.89 megapascals. So for the units of stress, we use in engineering megapascals, which is 1 million pascals, or this is 10 to the power 6 newtons per meter square, or 1 Newton per millimeter square, and 1 gigapascal is 10 to the power 3 megapascals. So we have the stress, we have the strain, then we have everything we need to calculate elastic modulus. 19.89 megapascals divided by 1.167 times 10 to the power minus 4. That gives us 170,474 megapascals. If you divide this by 1000, you get 170 gigapascals.